This is Jacob's Algebra, Chapter 13, Lesson 3, Part 2, continuing with solving polynomial equations by graphing. I'm sorry I cut out right in the middle of what I was saying at the end of the Part 1 video. I was not watching the time and didn't see that I was at the end of what I could do. So, we were working through number 6, Part B, and what that question asks us to do is to use the graphs we drew for Exercise 5 to find solutions to the equations. So we looked back at our graph for number 6b, which is this one. I'm sorry, for number 5b. And this is the graph that I drew. And we had to find where the curve crossed the x-axis. It crossed at -4 and it crossed at +3. And so then we needed to check that in our equation to see if that actually solved the equation. If it is a solution to the equation, it will equal 0. So we plugged in x equals -4 and wrote -4 squared minus 4 minus 12 because our equation was x squared plus x minus 12. Even though it's plus x, our x is a -4, so that's why it's a -4. So 16 minus 4 minus 12 is 0, so that does work. X equals -4 is a solution. Now we're going to plug in x equals 3. So our equation is 3 squared plus 3 minus 12. So 3 squared is 9, and then we're going to add 3 and take away 12. 9 plus 3 is 12, minus 12 is 0, so that means it works. So our solutions for Part B are -4, x equals -4, and x equals 3. Those are both solutions to the equation. Now we're going to look at Part C. So we're going to pull up our graph again. And this time we're going to look for our Part C graph. So let me get that up here. Here we go, Part C. So this is our graph, and we can see it crosses the x-axis 3 times. It looks like that's at -2, 0, and 2. The equation for this one was y equals x cubed minus 4x. Y equals x cubed minus 4x. And so we're going to try that for x equals -2, for x equals 0, and for x equals +2. So when x equals -2, we're going to do -2 cubed, and that's -8, because remember, when you raise a negative number to an odd power, it stays negative. Anytime you raise any number to an odd power, it's going to keep whatever sign it started with. When you raise a number to an even power, it will come out positive. But when you raise it to an odd power, it will be whatever sign you started with. So we plugged in -2, and -2 cubed is -8. And then we're going to subtract 4 times a -2. So we have -8, and then -4 times -2 is a +8. -8 plus 8 is 0, so that works. X equals -2 is a solution. Now we're going to plug in x equals 0 into our equation. So we have 0 cubed minus 4 times 0. Well, that's 0 minus 0, which certainly equals 0, so x equals 0 works. That is a solution. In fact, I need to go up here and put my check marks next to what the actual solution was. So then we're going to try x equals 2. So we're going to plug that into our equation, and we'll have 2 cubed minus 4 times 2. 2 cubed is 8. Minus 4 times 2 is -8. 8 minus 8 is 0. That means x equals 2 is indeed a solution. So now we have just one more to look at, which is Part D. So we'll go back and look at our graph for Part D. So this is our graph for number 5, Part D. And you can see it looks like it crosses the x-axis here at x equals 0. So our equation for that one was y equals 1/2 x to the 4th. And so we're going to try that for x equals 0. Well, 1/2 of 0 to the 4th is going to be 0, because 0 to any power is 0, and any number multiplied by 0 is still going to be 0. So that means that x equals 0 is a solution. Okay, so now let's look at the next problem. Number 7. Number 7 and 8 are just like numbers 12 and 13 that I assigned for homework. So number 7, you have quadratic functions that you are given. You need to graph each one on a separate axis And then you will use those graphs in the next problem. So for number 7, part A, the equation we have is x squared minus 6x plus 7. And so what we're going to have to do is do a data table. So we're going to make an xy data table. This is our x, and then our y is x squared minus 6x plus 7. And let me draw my lines. And remember, I have given you the values I want you to use for x. These are values that will make sure that you see what it is that you need to see for the graphs. And it gives you reasonable values to graph so that your graphs aren't crazy huge. So I chose the values from 0 to 6 for x. 0, 1, 2, 3, 4, 5, and 6. So when I plug 0 into this equation, I get 0 squared minus 6 times 0 plus 7, and that's 7. When I plug 1 into the equation, I have 1 squared minus 6 times 1 plus 7. Well, 1 squared is 1, minus 6 times 1 is minus 6, and then plus 7. 1 minus 6 is negative 5, plus 7 leaves me with 2. Now I'm going to do this for 2. 2 squared minus 6 times 2 plus 7. 2 squared is 4, minus 6 times 2 is minus 12. Plus 7. 4 minus 12 is 8, plus the 7, 4 minus 12 is negative 8, plus 7 gives us a negative 1. Okay, so now we're going to do this with 3. We have 3 squared minus 6 times 3 plus 7. 3 squared is 9. Minus 6 times 3 is minus 18. And then we have plus 7. 9 minus 18 is a negative 9. Plus 7 is going to give us a negative 2. Now we're going to plug in 4. We have 4 squared minus 6 times 4 plus 7. Okay, 4 squared is 16. Minus 6 times 4 is minus 24, and then we have a plus 7. 16 minus 24 is a negative 8, and then when we add 7, we get a negative 1. Now we'll try 5. 5 squared minus 6 times 5 plus 7. 5 squared is 25. Minus 6 times 5 is minus 30 plus 7. We have 25 minus 30 is negative 5 plus 7 is a positive 2. And then we'll do this also for 6. We have 6 squared minus 6 times 6 plus 7. 6 squared is 36. Minus 6 times 6 is negative 36. And then we have a plus 7. And that will equal 7. So now we just need to look at the graph for this. So let me pull up the graph. Here is number 7, part A. And I can't actually make it fit on here. Let me see if I can squeeze this over a little bit. Still can't make that fit on here and see the data table. Okay, so this is our graph for number 7, and we can see that it crosses the x-axis 2 times. Okay. I'm not going to actually go through all the calculations for number 7, parts B, C, and D. What I gave you in the homework email, the values I want you to use for x, plug those values into your equation just like I did right here. And once you've plugged those values in, you will get your y values. Use those to draw your graph. Okay, so now we're going to move on and look at number 8, the last problem. It says, from the graph of a function, it's possible to tell the solutions of an equation. So sometimes you can't tell exactly where it's crossing the x-axis because it's in between 2 squares. You can tell it's somewhere in a range. So for this problem, you just have to tell what 2 integers it crosses between. So let's look at our graphs. We're doing number 8 now. So for number 7, when we look at the graph, we can see that we cross the x-axis right here. Well, this is 2 and this is 1, so it crosses between 1 and 2. And then it crosses again right here, so it crosses between 4 and 5. So if we were going to write our answer for number 8, part A, we would say between 1 and 2 and between 4 and 5. Okay, so now we're going to look at part B. So we just go over to our graph for 7b. Again, we can see that it crosses the x-axis 2 times. And it looks like it crosses right here Notice this is between -4 and -3, not between -4 and -5. The negative side of the number line is numbered backwards. Here's -4. This is a -3. So we're going to write for 8b between -4 and -3. And then it crosses also right here. That's between -1 and 0. So I'm going to write between -1 and 0. You do not have to give an actual estimate of the value. You just have to say which two integers it is between. Please don't give me, 3/4 or 2/3. That's not what the question asks for. It says between what two integers are the solutions of the following equations. Use your graph to figure this out. So next we're going to look at 8c. For 8c, we go back to our graph for 7c. So that's going to be over in this corner, if I can get it to slide correctly. Okay, so here's our graph for 7c. It doesn't cross the x-axis anywhere. It's completely above the x-axis and never crosses it. So what we're going to write is no solution. Because it does not cross the x-axis, there is no value you can plug into that equation for x and have it cross the x-axis and have it equal to 0, because the graph never crosses the x-axis. So now we're going to look at part D. And like most of these, it crosses the x-axis twice. We can see it's here in between -3 and -2, and then it crosses again between -2 and -1. So for 8D, I'm going to write between -2 and -1, and also between -1 and 0. So let's go back and check that. Oh, not between -1 and 0. I'm sorry, I take that back. Between negative, okay, what did I write? Let me check my graph again. It's between -3 and -2. And then between -2 and -1. Okay, so between -3 and -2, and between -2 and -1. So be careful when you're reading your graphs that you actually pull the right numbers, because I started pulling the wrong numbers on that. That's something you have to be very careful of. So you can see it crosses in two places. Over here is between -3 and -2, and the one on the right is between -2 and -1. So that is all for this lesson. Be very careful on your graphing. Watch out whenever you're punching numbers into a calculator that if you have a square, that you close your parentheses when you hit that square so that your calculator knows what's included in the square and what's not. Same thing for square roots. Just be very careful entering things into your calculator, and please show me as much of your work as possible.